Differentiation, right? People don't like differentiation at the moment, but the process is not very difficult once you get the hang of it. To differentiate it, you just look at this one, right? 5,000x, it's going to be 5,000. We can think of that as 5,000x to the 1. Whoops. And we take the power, we multiply that. So that if this is y, we take dy by dx is going to be, we take the power, we bring it to the front, so it's 1 times 5,000x. And then we bring the power down by 1. And we do the same for 625x squared. For that bit, it's going to be 2 times 625x, and we bring the power down by 1. Okay, so that's the basic principle. You take the power, bring it to the front, and then bring the power down by 1. So bring it to the front, multiply it by that expression, and then bring it down by 1. So what we end up with is 1 times 5,000x to the 0. Anything to the 0 is 1. So 5,000 times 1 times 1 is going to be 5,000. And then we've got 2 times 625x to the 1, which is x. So it's going to be 1250x. So that's our answer. Find the coordinates of the turning point on the graph of this. Right, turning points are where dy by dx equals 0. So we know what dy by dx is. It's 5,000 minus 1250x. So if that's going to equal 0, we can add 1250x to both sides. And divide by 4. And we get x equals 4. Is that the answer? No, because we want the coordinates. So we know the x value. How do we get the y value? Well, go back to the equation. Y is given by 5,000x minus 65x squared. So y is going to be 5,000 times 4, which is 20,000, minus 65 times 16, which is 2. Is it the same? Is that 0? I think it is. So I think the answer is 40. State whether this turning point is a maximum or a minimum. Right. What type of equation have we got? If we take a look at that, it's 5,000x minus 65x squared. What's the highest power of x? It's x squared. So it's a quadratic. I'll put that in the reason. Now, there are 2 types of quadratic. You've got a happy quadratic and you've got sad quadratic. The difference is that one has got a positive amount of x squareds and this one's got a negative amount of x squareds. If you take a look at the x squared coefficient here, you'll see that it's minus 65, which means that it is a sad quadratic. So you don't say sad quadratic, you say negative. Negative quadratic. And that's the reason why the point where the gradient is 0 is at the top of a negative quadratic. It's at the bottom of a positive quadratic. And if it's at the top of a negative quadratic, that makes it a maximum. So if it's a negative quadratic, then the point where the gradient is 0 is going to be maximum. If it's a positive quadratic, the point where the gradient is 0 is going to be a minimum. Now, a publisher has to set the price for a new book. The profit depends on the price of the book, where y equals 5,000x minus 65x squared. So what price would you advise the publisher to set for the book? Well, you know that the graph for the profit is going to look like this. And we assuming that even though he's in publishing and he's doing something sort of vaguely educational and moral, that he wants to make as much profit as possible. Therefore, he wants the highest profit, which is going to be the peak. So that point there. So there's the biggest profit. So what price would you advise the publisher to set for the book? Well, it's the now that probably means that my calculations for the first bit were wrong, doesn't it? Yes, it does. When I said that was 0, what I really meant to say was it was 15,000. I changed things slightly. So yeah, okay, is that relevant? Yes, it is. Anyway, the price that you would advise the publisher to set for the book. Well, okay, the price for the book is X, and the profit is Y. Now, we know that the point where the profit is biggest is at the top of this graph. And so we need to find, I don't know where it crosses the axis, it doesn't really matter. But there's the price X, and there's the profit Y. And so we need to know that the price value that gives us the highest profit. Well, that was given at the turning point. If we go back to the answer for part B, we can see that when X is 4, we had the highest possible profit. So that means £4 gives us the maximum profit. So really, this last part is just interpreting what all that maximum minimum stuff is about and how it relates to the numbers. That's quite an important question, actually, 14 part D. And I hope you understand how that works, because they haven't asked that in a paper that I've done before. But it does just illustrate how maximum and minimum work and how it's applied in this particular situation. So please take your time to make sure that you understand that question, because it's a good one.